Good evening, everyone. Tonight, it's an incredible privilege for me to be here. My name is John Mandelman. I am the Vice President for the Anderson Cabot Center for Ocean Life here at the Aquarium, which launched in June and encompasses all of our research and conservation programs here at the Aquarium, where we're doing solutions-based science work to try to address the biggest threats facing the oceans. And it's a privilege tonight to be able to introduce someone else who is going to introduce our speaker. But I wanted to just give a quick preface about our Marine Conservation Action Fund, which otherwise known as MCAF, which is at the centerpiece of tonight's lecture and what allowed our incredible speaker, Daniel Fernando, to be here tonight. And in a minute, I'm going to introduce the manager for MCAF, Elizabeth Stevenson, who's done an absolutely amazing job coordinating this incredible micro-granting program that provides small grants to address urgent conservation issues around the world. And you'll see tonight, for those of you that haven't seen Daniel before, because he has been here and done an amazing work or presentation work here in the past, you'll hear a little bit more about the context of MCAF, and you'll hear about how it's had an effect on his professional growth and career. So without further ado, I'd like to introduce Elizabeth, again, the manager of our Marine Conservation Action Fund, to talk to you a little bit about MCAF and then introduce our speaker for tonight.
Good evening, everybody. Just wanted to say, as John did, thank you so much for coming and supporting the lecture series and supporting really the MCAF program, our fellows, by showing such interest in their work. So as John said, the Marine Conservation Action Fund is a micro-granting program that funds projects all over the world. And MCAF is truly a global program. We have funded projects on 6 continents and in more than 40 countries. And in addition to supporting conservation projects around the world, such as protecting sea turtle nesting beaches, such as studying the highly endangered Indus River dolphin in Pakistan, such as starting the first marine mammal stranding network in the country of Iran, or aiding the scientists to help advise the whale watching industry in Costa Rica to have guidelines that are safe for marine mammals. We go beyond offering grants to our grantees, and we seek to have long-term relationships with the people we fund and to support them with all the resources that the aquarium can offer. And to this end, we have created the Marine Conservation Action Fund Fellows Program, and Daniel is here tonight as one of our fellows. Has anybody seen any of our previous fellows? Asha DeVos, who talked about blue whales, or Kirsten Forsberg, who talked about manta rays, or Ruth Leaney and her sawfish. So it's great to see some repeats here tonight for our fellow Daniel Fernando. So when our fellows come to the aquarium, they spend time meeting with our educators, our visitor educators, learning about sharing their work with the educators, so then the educators can share their work with visitors, and also learning communication strategies from our educators about how they can better share their own work with the public. And they also meet with our scientists, such as John Mandelman and other scientists in the Anderson Cabot Center, and exchange information. Daniel's already working on some collaborations with some of our scientists while he has been here. And in addition, we have them go to our into the main building, to the exhibit space, and this is our Blue Planet Action Center. And this is Daniel Fernando doing his best imitation of a manta ray for explaining just how big they are compared to like the cow-nose rays that we have in our shark and ray touch tank. And Daniel, like I said, we work to establish long-term relationships, and Daniel's been in the aquarium family for quite a number of years now. MCAF supported his work in 2012 to, you'll hear more about it tonight, but to investigate the impact of the gill trade of Manta and mobula ray gills in Sri Lanka. And that work ended up creating significant conservation measures for these species that he'll tell you about tonight. But he came as one of our first ever MCAF speakers before we even had a fellows program, and spoke in 2013. Did anybody see his lecture? No. Okay, great, thank you. And so you may remember Daniel from that time, and came and toured the aquarium and also met with our educators. So seeing the scope of Daniel's work and how much he has accomplished which is true of all our fellows. It's really humbling to see how much they've accomplished, even just in a few short years. It's really a pleasure to have him back here tonight. Before I introduce Daniel, I just want to thank the foundations and individuals that make this program possible. Our Fellows program is supported by the Institute of Museum and Library Services. The New England Biolabs Foundation supports the MCAF granting program and is here tonight. The Curtis and Edith Munson Foundation have been supporters of the MCAF program since 1999 when it was founded. We have many generous individual donors, some of you who are here tonight, so thank you so much for supporting this valuable program at the aquarium. We have a committee of scientists that gives their time to review all of our proposals. So I just want to thank them as well, along with the aquarium, of course, for supporting this program, the Lowell Institute, and of course our grantees and fellows for all the great work they're doing around the world. So on to Daniel Fernando. Daniel is a marine biologist and conservationist based in Sri Lanka. As an associate director of the Manta Trust and Ph.D. student at Linnaeus University, he has spent several years studying the biology and ecology of manta and mobula rays, primarily in the Indian Ocean. Over the last 2 years, he has been actively involved in supporting shark and ray listings at international conventions such as CITES and CMS, while working to advance the protection and management of these species on a national level in Sri Lanka. He's the co-founder of Blue Resources, an organization that facilitates scientists and students to conduct marine research and conservation initiatives in Sri Lanka. He is also currently an advisor to the Ministry of Sustainable Development and Wildlife of Sri Lanka for marine species and conservation conventions. It is my honor and my pleasure to turn the podium over to Daniel Fernando.
Thank you so much for that very kind introduction. And thank you all for coming here today. I really appreciate this. And before I begin, I would just like to say that it's an incredible honor to be invited back here again. And I'm really appreciative of the Marine Conservation and Action Fund that helped me conduct some of the baseline research in Sri Lanka, which really helped us not just better protect these species, but also give me an opportunity to sort of grow and come to where I am today. So for that, I'm incredibly grateful to MCAF and also to the New England Aquarium. So thank you for that. Additionally, of course, I would like to also thank all the other partners and funders I have had over the last few years. So before I begin, I would just like to ask, are all of you familiar with manta and mobula rays? Has anybody here actually gone swimming with a manta ray? If you can just raise your hands up. Yeah, so we have a few people. Just to clarify, because this question comes up quite often, these are not manta rays. So these are cow-nose rays and stingrays. A lot of people always ask me the question, was Steve Irwin killed by a manta ray? And no, it was a stingray. So it's part of the same family, but completely different species. So manta rays actually have no sting on them at all, so they're completely harmless. So just to give you an idea of what a manta ray is, we have this very short video here which shows one of the two species of manta. This is the reef manta, and this is the smaller of the two species. And by small, I mean from wingtip to wingtip, we're talking about 10 feet. This species, what you saw in this video here, is just doing these barrel rolls, and the reason for that is that there is a high density of plankton in this area, so it's just taking advantage of that and feeding in this dense patch of plankton. Here we have a photograph of the other manta species, which is the oceanic manta. This actually gets a bit bigger, so wingtip to wingtip, we're talking about 20 feet in a mature adult. So it's a considerably large animal if you're swimming out in the ocean and you see one of these come up to you. And traditionally, of course, fishermen have always been a bit afraid of these because they were not really sure whether they're harmful or not. But again, as many divers know, all across the world, these species are completely harmless. A good way to describe rays in general is that they are essentially flattened sharks. So if you take a shark, run a steamroller over it, you have a ray.
They're very sort of prehistoric animals, and yeah, I mean they are very well adapted to the environment that they live in. So as I mentioned, you get the two manta rays, and in the larger family of Mobilidae, you have the genus Manta and the genus Mobula. So the Manta, as I mentioned, there were two species. The Mobula, which is what a lot of the work that we've been doing over the last 3 years has focused on, a group of 9 rays. So they look very similar to manta rays, and we actually refer to them often as either mini mantas or the smaller cousins of manta rays. The other common name that's used for these species are, of course, gill rays. And it's quite obvious when you look at them because they have the 2 cephalic fins, which basically at the head look like 2 horns of a gill. I'm going to show you a short video and you'll see these mobula rays breaching out. And this is one of the reasons, again, why fishermen refer to them as gill rays, because you have these horned animals jumping out of the water coming towards you. But again, unlike other species, completely harmless, no stinger whatsoever, and they cannot hurt you. So here's just a short video. So this video that was taken by BBC was actually from the Sea of Cortez, and it's one of the 9 mobula species. This particular one is Mobula munkiana, and this species is known to aggregate in large numbers. So they have occasionally recorded them in schools of up to about 500,000 to 1 million individuals. So it's absolutely incredible when you see these spectacles of these large numbers of rays. And it shows that although they're sort of the mini mantas, they can be as charismatic as the large manta rays. This, of course, means that a lot of divers across the world do want to see these species and do travel to see them. Unfortunately, a lot of these species are facing global population declines. So when we look at the data that's currently available, so some of this is already old. For example, the manta ray data is from 2013. And in the 5 to 8 years prior to that, there were declines of ranging from about 56 to 86% on a global scale. The data for mobula rays from 2015 shows that over the last decade, declines of up to 99% in certain populations have been recorded. So this is, of course, an incredibly large issue when you consider how charismatic and how valuable these species are to the ocean. So of course, a lot of questions were raised as to what is causing these population declines. And a lot of the work that I conducted in the field was related specifically to this. So what we found was that a lot of these species are being caught as non-discarded bycatch in tuna gill net fisheries. So this means when fisheries targeting tuna, generally for the export market, when they're laying out nets, they're catching manta and mobula rays by accident. But what we notice is that they're not always releasing them out at sea. They're killing them and bringing them back to shore, which means that these animals have some sort of a value to them. So of course, the first thing that everybody thinks is that it must be the meat. So we investigated, and what we found was that although there is a certain amount of meat being consumed, it's generally very small scale. So for example, manta rays have a very sandy texture in their meat, so it's not really consumed fresh. It can only be dried and sold as dried fish. A few of the mobula rays are eaten by certain local communities fresh, but at a very small scale. So this is not really the driving factor behind this fishery at all. So what we realized was that the primary factor that's causing the fishermen to actually kill these animals and bring them to shore was due to the gill plate trade. So the gill plates are basically the tough cartilaginous structures that you find inside the heads of these animals. And these are the structures that enable them to filter the plankton out of the water column. So as I mentioned earlier, these species are all filter feeders. They're feeding primarily on plankton. And these structures are being cut out of the heads of these animals, dried, and then exported to China for use in Chinese medicine. So these photographs are of the dried gill plates. So on the right-hand side, you can see these piles of gill plates, which is actually from one of the shops in China, in Guangzhou province. So you get a large quantity of these gill plates in those shops. And the studies on that side have revealed that they're being marketed for a wide range of ailments. So they claim that it can cure chickenpox, cancer, asthma, that it helps children with measles, and also general purification of the blood. So when we conducted a bit more research into this, although they were actually promoting this as traditional Chinese medicine, we realized that it wasn't very traditional at all. When you compare it to rhino horns, for example, which have been in Chinese texts for over 2,000 years, when you compare that to mobula rays, we found no evidence of these being around for that long. In fact, the first reference for Manta or mobula gill plates in Chinese texts is from 1968. So it's quite a recent introduction into Chinese medicine. And this trade really only expanded and grew from about the mid-1990s onwards and into the early 2000s. And we believe that it was most likely due to a decline of other species in the Chinese trade. So traders were essentially looking for an alternative that they could market. And these were the unfortunate victims that were chosen. So of course, this issue is really compounded by the fact that both Manta and mobula rays have extremely conservative life cycles. So we know that they mature very late, and they give birth to just to one single pup. So actually the photographs that you can see here on the bottom is a baby mobula ray. This is an unborn mobula. And as you can see, it's got its wings curled up, basically like a burrito. And when it's born, it'll unfurl its wings and start swimming about. So generally, when we look at manta rays, we know that they take about 15 years before they actually become mature. For mobula rays, we're not exactly sure of the numbers because the data is really lacking, but it seems to be anywhere between 5 to 8 years. Both species give birth to only one single pup. Manta rays give birth to one single pup every 3 to 6 years. Mobula rays maybe once every 2 years. We're not very sure. This means that they have extremely low reproductive cycles in general. One of the other issues is that these species have very few natural predators out there. So they're actually extremely fast in the water. So the few animals that could potentially attack them are generally large sharks like tiger sharks or orcas. But manta rays have also evolved to take care of this issue. So most of their organs are actually concentrated in the center of their body. And as I mentioned, they're incredibly fast. So generally, sharks can only get a bite out of one of their wings, the pectorals on either side. But again, these animals are quite resilient. So here you can see on the left-hand side, you can see a photograph of a manta ray where a shark has taken a nice bite out of it. The other photograph there in the center is the same manta ray 1 year later. So you can see that it has almost completely healed itself. Let's see if I can. Yeah, so where I'm marking here, this is basically the old wound there, and you can see a bit of the scar tissue. We know that it's the same manta ray because manta rays have a unique spot pattern on their bellies. So looking at that, we can identify each individual manta ray. So this also shows us these animals have an incredible capacity to regrow themselves almost. And again, this is something that is quite interesting to study because, of course, we would love to do this in humans. So all of this compounded with the fact that they have extremely slow growth rates. Manta rays can live 40 to 60 years. Mobula rays probably over 15 or 20 years. Means that any targeted or large-scale fisheries on these animals will most certainly be unsustainable. So what I have spent a lot of my time doing is going to fish markets and identifying the animals that are being landed. So a lot of this work was done in Sri Lanka, where I'm from, some of it in other neighboring countries, including India, Malaysia, and so on. And what I would do is go and identify each specimen that's being landed, identify it down to species level, and collect tissue samples. So I've gotten quite good at this because I've been doing this for quite a while. In case you're wondering how much I've aged since my first survey, this will give you an idea. So it's been quite a tedious process for me. But basically, a lot of the data that I collect is very, very basic, but it gives us a lot of information about these animals. So we're looking at very simple measurements, for example, the width and the length of the animals, their sex, and the maturity. We also collect additional information, for example, on the fishing gears used, whereabouts they're getting caught, and also on selling price to give us an idea of supply and demand. One of the other issues that we encountered during a lot of this work was actually dealing with the identification of these animals. To distinguish between Manta and mobula is generally quite easy, but then we have the 9 mobula species, all of which look incredibly similar to each other. So this was another reason why there was very little data being collected on a global scale. People were having issues identifying the differences. On a very basic level, people were mistaking mobula for Manta and vice versa. And then even more experienced field researchers were not at all being able to identify down to species level. So one of the things that we've been working on is to create a global identification guidebook so that we can encourage researchers across the world to use this guide to identify specimens down to species level so that we can collect better data. And of course, all of this data is essential for better management and conservation of these species. The other thing that we do a lot is sampling. So you saw that I was collecting a small tissue sample in one of those previous pictures. And these tissue samples are sent to our partners who then work on a variety of techniques. One of them is DNA barcoding, which basically is a genetic identification kit. So instead of visually identifying specimens, we can take a small tissue sample and identify them down to species level on the genetic level, which is quite important when you're trading these animals at an international level. So sometimes it might just be the gill plates, sometimes it might just be the meat. So now we can identify them down to species level. These tissue samples also enable us to collect a lot of information about their population connectivity, for example, whether the Indian Ocean population is connected to the Pacific and vice versa, and also sometimes on a more regional scale. We look at stable isotope analysis, which is essentially getting a better understanding of what they're feeding on. And again, we can compare this to different regions in the ocean to identify where these animals have been traveling to. So of course, a lot of this data is, as I mentioned, incredibly important for the management and conservation of these species. And this is where I have been playing sort of 2 roles in general, the first being a researcher in the field, and the second is more from a policy perspective. But of course, a lot of countries have realized the potential of conserving these species even before we started these actions. And the reason for this is simply due to the fact that a manta ray alive over its lifetime is worth about $1 million US, whereas when it's dead, it's only worth about $500 US. So these very simple figures mean that a lot of countries that have the potential for manta and mobula ecotourism have an added incentive to keep these species alive instead of fishing them. So some of the great examples of this have, of course, been the Maldives. And here's just a short video of some of the manta ecotourism that takes place in a place called Honeyfurrow Bay in the Maldives. And this is a very small bay where a lot of plankton during certain times of the year accumulates in large quantities. And by small, I'm talking it's about the size of 1 or 2 football fields. And at certain times of the year, you can actually have about 250 manta rays in this small bay. This is actually a slow day, there's not much happening. But you can still see, as a tourist, it's an incredible experience. The same thing is happening with mobula rays to some extent. A bit less, because then these species do not aggregate as much as manta rays, so it's usually harder to encounter them. With the exception of mobula munkiana from the Sea of Cortez, which aggregates in large numbers, a lot of the other aggregations for mobula rays are not very reliable. So this photograph is actually taken from the Azores Islands, where you get one species called mobula terrapacana, and they can aggregate sometimes in about 5 to 25 or 30 individuals. So it still gives you an incredible encounter with these animals. And as people are collecting more and more data using these identification guides that we have developed, we realize that a few more of these potential aggregation sites are being identified across the Philippines and Indonesia, which gives, again, an added incentive for some of these countries to work at protecting these species. However, that's not always enough, because sometimes countries require a bit of additional motivation to better conserve these species. And this is where we have been doing a lot of work with one of the largest conventions dealing with wildlife in the world. And this is CITES, or the Convention on International Trade in Endangered Species of Wild Fauna and Flora. So just to give you a very brief summary of this convention, it's the largest convention. There are 183 countries in the world that are part of this convention. And basically what it does is it keeps a control on any species that are listed under this convention the moment they are created at an international level. So if there's a species listed on this convention and it crosses an international border, it can only cross such a border if it is accompanied with the appropriate import and export permits, along with another document called a non-detriment finding. And this non-detriment finding, or NDF, is actually the most important document because it's very scientific in nature, and it's essentially a study that has looked at this specific stock from where this species has been taken out to determine whether it's sustainably harvested or not. So essentially, if these species are being traded, it can only be done if you can certify that it has come from a sustainable stock. So in 2013, manta rays were listed on this convention. So this meant that they could not be traded any longer unless you could certify it sustainable. And as yet, there hasn't been any country able to do that, given the extremely conservative life cycles of these species. And it's unlikely that any will be able to do so in the near future. So this has greatly improved the protection of these animals. In addition to this, there is the sister convention called the Convention on the Conservation of Migratory Species, which basically deals with animals that travel across the region. And in 2014, thanks to the government of Fiji, who we were actually able to advise and help, they put forward a proposal to list both manta and mobula rays under this convention, and it passed successfully. So what this convention does is that it encourages countries within certain regions to work closely together to better protect these species. So this convention is not as strict as the other convention CITES, because CITES can actually blacklist countries if they don't do something properly, which can negatively impact their economy. Because CITES deals with a lot more than just marine species. We're talking of timber, a lot of plants like orchids that are being exported, and a lot of birds. So the moment a country gets blacklisted, it has a severe negative impact on the economy. CMS is a bit different because it's more of a convention that recommends that countries work together to protect these species. So as I mentioned, in 2013, we had manta rays listed under CITES, but mobula rays had not been listed at that time. So the big goal was to try and get mobula rays listed on this convention because that would give them a lot of added protection. And the CITES meeting basically takes place every 3 years. So the next meeting was in 2016. So we essentially had 3 years to scramble, collect as much data as we can about mobula rays. Because in order to put forward a proposal, it has to be very scientific, which means that you need a lot of information about the places where these animals are being found, the numbers, how many are getting caught, and the other dangers that they're facing. So we basically had 3 years to work on this. In addition to that, at the same time, I was getting a bit more involved on the shark side of things. So I started working a bit more closely with the government in Sri Lanka. And the reason for this was largely due to a change in Sri Lankan politics. So prior to 2015, we had a government that was extremely difficult to work with. They were not interested in conservation at all, and it was all about developing the country. So you couldn't really get much across to them from a conservation perspective. But in 2015, the government thankfully changed, and we had a lot of new ministers in charge. So actually in this photograph, you can see the Minister of Wildlife, who I'm actually an advisor to now. And thankfully, he was extremely interested in conservation in general. So due to his interest, I was able to play a leading role for Sri Lanka to further our protection of sharks and rays, and at the same time get involved in a few other things which I didn't really expect. I'll tell you about that shortly. So as I mentioned, I was then sort of part of the Sri Lankan delegation that would then attend CITES. And the government of Sri Lanka put forward a proposal to list thresher sharks on CITES. So again, this would mean that if thresher shark fins are being traded at an international level, they would be controlled by this convention. And thresher sharks, like a lot of other sharks and rays, were also facing global population declines of over 70%. In addition to the thresher sharks, the government of Fiji, again, took a great step forward and submitted a proposal to list mobula rays. And again, I was fortunate enough to help the government of Fiji from a technical perspective as well on this proposal. The government of Maldives then took up the silky shark proposal. So we had this nice group of 3 countries, very small island nations that were really taking very large steps from a conservation perspective. And this photograph here is actually a picture of most of our team that was working on the thresher shark and the mobula ray proposal. So we have this small group of very like-minded individuals that had formed this very cohesive strategy to get these species listed. And it was not just governments working on this, of course. There was a large group of NGOs from all across the world that were providing incredible amounts of support to the governments and to the proposals to get these listed. Because a lot of work goes into this. It takes about 6 to 12 months to develop one of these proposals, and then a country has to, of course, submit it officially. Then you have about 1 year's time before the actual meeting takes place to get as much support as you can from all the other countries that are party to the convention to make sure that they vote in favor of this proposal. So I was quite fortunate to spend about 6 months to 1 year of my time traveling on behalf of the government of Sri Lanka to various countries and various meetings to basically gather as much support as we can for the thresher shark proposal, because that was our primary proposal. But at the same time, Sri Lanka had already publicly stated that they would support the mobula and the silky shark proposal. So thankfully, I was able to campaign as well for the mobula rays, which was my personal interest. It was quite interesting because I got to visit a large number of countries, but unfortunately, a lot of the time you just get into a country, go to a windowless room for about 1 or 2 days, give a few presentations, talk to a lot of government delegates, and then leave. So you don't really see much of the country. That was the unfortunate part. But a lot of it basically included building relationships with various government officials, getting to know them better, and basically, establishing vital contacts that will help us get their support in the future. And of course, showing the benefits of protecting these species, both from an ecotourism perspective, from a sustainable fisheries perspective, and so on. So finally, in October of 2016, we came to Johannesburg in South Africa for the CITES convention. So it was the 17th meeting of this convention. This photograph is actually on the top right of our Sri Lankan delegation. So we were quite a small group of people. And it was a similar situation, of course, for both the Fijian government and the Maldivian government. We were all there as very small delegations. But of course, this meeting is incredibly large. So you can have about 2,000 to 3,000 delegates in total attending this meeting that takes place every 3 years. And it can be quite daunting being there because there's just so much being discussed. It's not, of course, we're there just for sharks and rays, which is a very small component of this entire convention. There are people there just discussing about timber trees, pangolins, elephants, and a whole variety of other species. So this meant that occasionally I was also getting called to discuss some of these other species because our delegation was so small. So I actually ended up speaking, in favor of supporting proposals to protect pangolins, attending meetings with various countries to improve the protection of other species as well. So a lot of this involved a lot of bilateral meetings with various countries and just negotiating with them and getting their support for a proposal. So it's a lot of work, and actually even at the convention itself, which takes place over 2 weeks, you can get a lot of additional support at the last minute. So it's incredibly vital that you're just constantly going out, speaking to people and making sure that everything is going smoothly. And all of this work, about 3 years of work, gathering data, getting the support of these countries, just boils down to about 15 or 20 minutes on the floor when it comes to your topic on sharks and the voting procedure that then takes place. Of course, being the only delegate on the Sri Lankan delegation who knew anything about sharks and rays, I was up there speaking, defending the proposal from various other countries that were not in favor of this proposal. So it's a bit of a debate that takes place on the floor, and you have to counter some of the arguments that other countries put forward as to why these species potentially should not be listed. But overall, it was actually an incredible success. And all 3 proposals, the thresher shark, mobula rays, and silky sharks, were successfully adopted at this convention last year. And this as you can imagine, actually everybody was just jumping up and down. It was crazy. But the reason for that was because in the past, whenever shark and ray proposals had been put forward, they never really passed on the first attempt. It usually took about 2 or 3 attempts. And when you're talking about 2 or 3 attempts, you're talking of 6 to 9 years before a species gets listed on this convention. So it's a lot of time and effort that people have to put into. And we were very fortunate to have had this very strong team that had this excellent strategy and were able to get the support needed to pass it on the first time. And it passed with such large majorities that even countries who are generally against marine proposals, like Japan, for instance, they were unable to actually reopen this proposal for discussion just because the majority was so high when it passed. So that was an incredible success, and it really showed that governments across the world saw the need to protect these species and that there was this growing momentum to protect them further. So as a result of this incredible success, we now have mobula rays and thresher sharks listed on this convention. And actually from the 4th of April onwards, mobula rays this listing will be implemented. So there was a 6-month delay to give countries some time to bring their national legislation in place. For the sharks, there was a 12-month implementation phase. So from the 4th of October of this year, implementation will take place. So what we'll be doing over the next few months is essentially working with governments across the world to make sure that they have all the tools in place to properly implement these listings, which means working with them to train them on identification of species, that when the fins or the gill plates of these species are crossing international borders, that they're able to identify and know that this is a protected species and not an unprotected species. So in addition to all this international work, I was also, of course, interested to develop something on a national level in Sri Lanka. So one of the great things at CITES was the fact that Sri Lanka had really changed its perception on conservation, and it realized that there is the need for conservation in Sri Lanka and that it's a good thing to do, essentially. So one of the things that happened was that Sri Lanka actually put forward a bid to host the next CITES meeting. And we actually won the bid, which means that in 2019, Sri Lanka will be hosting the largest convention in the world to discuss the conservation of wild animals. So this was actually an incredibly proud moment for me, because we had just gone from a state where Sri Lanka didn't recognize conservation, didn't care about sharks and rays at all, because we are one of the largest shark fisheries in the world, to a country that put forward a proposal to protect these species at an international level, supported other proposals to protect additional species, and took the extra step to actually bring this convention back. So of course, the fact that we are bringing this convention back secures our commitment to the natural environment in Sri Lanka for quite a few years to come. And as part of this, one of my personal interests was, of course, to advance marine research in general. And unfortunately, there are very few people studying the marine environment in Sri Lanka. A lot of research to date has focused purely on the terrestrial side, primarily due to the ease of it, and second, due to the fact that we had a civil war in Sri Lanka until 2009, so venturing out into the ocean was generally not permitted. Of course, things have changed now. So I actually took the step with another colleague of mine to set up an organization called Blue Resources Trust. And this organization is basically acting like a research platform in Sri Lanka, where we encourage both national and international researchers to come into the country, conduct additional marine research so that we get a better understanding of our environment. And actually, setting up this organization was largely possible due to a grant that came in from a local company called Tokyo Cement, which is actually a cement company in Sri Lanka. And they were very supportive of this project because they had a special interest in coral reef conservation and restoration. So our main aim at Blue Resources is to look at sort of the connectivity between marine ecosystems in general, to raise awareness on how we impact our environment, which is a big issue in Sri Lanka because we have, unfortunately, a lot of issues when it comes to pollution from pesticides and also plastic in general. And then one of the other factors that I'm personally interested in is, of course, ensuring that any trade taking place is fully sustainable. We'll be having a few areas that we focus on. One of them is, of course, coral reefs, where we'll be doing a lot of long-term monitoring studies and also some community-level conservation. We have done a few interesting programs where we have worked on developing capacity with the Sri Lankan Navy. So since the civil war ended, we still have a very large military in our country. But the great thing is that even the Navy have realized that there is a need for conservation in the country. So they reached out to us to ask for some additional training. So we have now been training them to change their diving techniques from going down to dismantle a bomb to actually surveying a coral reef. So we hope that this data that we get from them will then enable us to get a better understanding of the coral reefs around the country, because we are still a very small team of just a few individuals, but when we get the support from a large group like the military, we can achieve a lot more. We have some other projects planned in the pipeline. One of them is a collaboration with NOAA here in the US, where we'll be installing a coral reef early warning system, which will actually be the first in the Indian Ocean. So this instrument will basically give us a much better understanding of the general ocean conditions in that area and hopefully help us predict when there might be any situations where the water temperatures will rise very high and negatively impact the coral reefs. So all of this data will basically help us make more informed management decisions when it comes to the protection of coral reefs as well. One of our directors at this organization specializes in seagrass as well. So unfortunately, I can't tell you much about seagrass because I didn't really even know we had seagrass in Sri Lanka until a few weeks ago when I went and took this photograph. So this is, again, one of the issues that we have. We have very few people that know what's out there in Sri Lanka. So there's just so much that still needs to be done. One of the projects that we have going on in about a week's time is part of the Global Finprint, which is essentially this program to get a census of the shark and ray populations across the world. So it uses a standardized technique called BRUVs, which are baited remote underwater videos. And it's essentially an arm which has some bait on it, and then a camera that's focused on this, filming for about an hour. And you use that data to identify what species are coming in and to get an idea of species abundance. So hopefully this will give us a better understanding of the shark and ray populations in Sri Lanka, which is something I'm personally interested in, of course. So a lot of this work deals, of course, both on a national scale and also to some extent on an international scale. And just before I finish, I would just like to touch upon a few small things, and that's the role that we all have to play. First, as individuals, we have to ensure that we reduce our carbon footprint. This is something I'm sure you're all aware of. And the second thing is to make sure, or at least be very aware of what we are purchasing and consuming, so that we know where it's originating from and the issues that might be potentially coming with those items. Secondly, I think we really have to make an effort to make sure that our voices are heard. And this is very important, where we form cohesive strategies to make change at a larger level, just not at a personal level, but also at a larger scale, for example, by influencing policy. And again, we all can play a role in this. This is one of the critical numbers which not a lot of people talk about, but the reality is the growing population that we have is what's putting all the pressure on our natural environment. Technology is constantly advancing, which allows us to survive, but the environment is usually continuing to suffer. And as scientists, we really have a responsibility and obligation to focus on research that really benefits and contributes to the preservation of the environment in general. And we also have a sort of responsibility to actually communicate this data, because it's not enough that we just collect all this data. We have to make sure that it gets out there so that the general public can make use of it. And again, so that individuals can work together to develop these cohesive strategies for large-scale policy change. Unfortunately, of course, a lot of these issues can be exacerbated due to times of political uncertainty. As I mentioned previously, in Sri Lanka, we had this circumstance where we had to shift from an era where conservation was not thought of at all to one that did. And we have to remember that politicians will always only think of periods of 1 or 2 terms before they're just thinking of when they're getting elected next, and not of the future generations that are actually obliged to inherit the world that we live in. So although we often will live in times with challenging governments in various countries across the world, I think we have to be environmentally conscious, and we also have a responsibility to hold such governments accountable for any injustices that they may be committing. But at the same time, we really have to recognize that a lot of incredible successes have been achieved in the last 1 or 2 years, particularly when you're looking from my viewpoint, which when it comes to sharks and rays. The amount that we have achieved listing these species, getting awareness out there. We're seeing, for example, China taking steps to better implement CITES when it comes to sharks and rays. And all of this really indicates that countries, governments, and individuals across the world really recognize the need for sustainable management of species and for the general protection of the environment. So we are really taking steps in the right direction, but we have to increase our momentum and work faster. And changes at regional and international levels are essential, because after all, we have to remember that nature does not recognize any political boundaries at all. So with that, I would just like to show you this one last video, which is again of mobula. So I hope that with the actions that all of us take here, that we can ensure that our future generations will be able to see animals like this in the wild, alive, instead of just on video at cinemas like this. So thank you very much. So the question was what the horns are from on the Manta and mobula rays, what their purpose is. And that's actually a really good question. So both these species have these horns which are called the cephalic fins, and they generally use it when they're feeding. So the manta rays have extremely long cephalic fins. The mobula rays are a bit shorter, but their purpose is essentially that they unfurl them while they're swimming, and it essentially forms like a funnel which pushes more water into their mouth. And the more water that goes into the mouth, the more food that goes through their mouth. And the way they feed is that they're filter feeders. So all this water goes through the mouth, comes out the gills, and those gill plates, which I showed earlier, essentially act as a filter, filtering the food out of the water column. So these cephalic fins, or the horns, basically allow them to get a lot more water into the mouth. And when they're swimming about normally, they'll just curl them up, basically to streamline themselves. Yeah. So the question was why these species are important to the oceans. So it's quite a complicated question, actually, because one of the main answers is that we're not exactly sure why they're important. So it's one of the main arguments is, of course, that they're an incredibly charismatic species. So you could relate this, for example, to the panda on land. Do we want to actually lose this animal or not? Is it worth protecting for future generations to see? The other theories are that, for example, sharks, we know that they're keystone species. They play an integral role in the trophic chains and help keep ecosystems in balance. For manta and mobula rays, we're not exactly sure what that role might be and how large it could potentially be. Some of the theories are that it helps bring nutrients from the depths because a lot of these animals are able to dive extremely deep. For example, manta rays can dive anywhere between about 200 to 500 meters. Mobula rays have been recorded diving up to 2,000 meters, so 2 kilometers. Yeah, what's that in feet? I'm sorry, I'm bad at feet. Yeah, okay. More than a mile, I think. So, yeah, so these species are probably diving very deep and bringing up nutrients to the surface. And at the same time, when they die, they're taking a lot of food that a lot of other animals can live on. So it's basically like whale carcasses as well. So they might be playing multiple roles in the ecosystem. We're not exactly sure what. But again, the big question is, do we actually want to lose these incredibly charismatic species or not? Yep. So the question is whether there's any work being done to increase the populations through breeding. Unfortunately, the issue that's faced is that these species are extremely large, so it's not really possible to hold them in captivity and breed them in large numbers. The other issue is, again, that we know so little about these species, so we don't really know exactly how much they're feeding on, how often they reproduce. We have some indications of this, but the data is still severely lacking. For manta rays, we have a bit more information because they're commonly seen by divers and they're often found in similar aggregation spots. For mobula, this data is still missing. So at the moment, there's absolutely no program to look at increasing this population. So we have to rely on their natural capability to increase. And this, of course, means that in order for them to increase naturally, we have to reduce the pressures on them, which is, of course, fisheries and so on. Yep. So it's how to identify these rays also like a few years later if you take a photograph of the same individual. So for manta rays, it's extremely easy because they have this unique spot pattern on their underside, which is essentially like a fingerprint. So each individual can be identified. And this is how a lot of our data collection takes place for manta rays in particular. Because anytime we see one, we just swim underneath, take a photograph, and we maintain it in a database. And looking at these photographs collected over several years, we can identify where certain individuals have moved, how often we have seen them, which gives us an idea of how long they're potentially living. We can collect additional data on whether we saw them being pregnant or whether they're given birth and so on. Unfortunately, with the other species, the mobula rays, they don't really have any permanent markings on them, so it's not possible to identify them individually. We can, of course, identify them down to species level based on certain morphological identification characteristics that we use. But unfortunately, down to individual, it's not possible for mobula arrays. Yep.
Is there any education that's happening in countries like in China where they take things, they think that things are for aphrodisiacs or for curing cancer or for all this? I mean, it's probably at least an art myth. So is there any that would be diminishing the market for killing these animals if there was an education program?
Yeah, that's a great question. So the question was whether there are any education or awareness programs taking place in China to reduce the consumption of these species. And the answer is yes. There's actually one organization that's doing an incredible amount of work there, and that's called Wild Aid. I'm sure some of you would have heard of this organization. They have actually supported some of my work as well. And Wild Aid has been working very much on the shark fin side of things, dealing with the consumption of shark fin soup in general. They had incredible success when they got a few Chinese celebrities on board to sort of campaign. So they had this one basketball player called Yao Ming who has done an incredible amount of work in changing the perceptions of the younger generations. And they ran quite a few other campaigns, and they also focused on manta and mobula arrays. So actually, I conducted a study funded by them to look at the presence of toxins inside gill plates. Because similar to fish, we know that gills generally accumulate a lot of toxins the older these fish get and the longer they stay in the ocean. So what we identified was that certain heavy metals, like a common poison, which everybody's familiar with, arsenic, is actually present in very large concentrations in these gill plates. So this meant that although they were marketing this as a cure for a variety of illnesses, they were essentially marketing a poison. And this was a big issue because they were also promoting it for little children under the ages of 5. So this was something that Wild Aid really ran a large campaign with to show that it doesn't have medicinal properties and it's actually detrimental to one's health. And this has helped a great deal. Unfortunately, with manta and mobula arrays, a lot of the consumers are generally the older populations, older generations, so it's often a bit harder to convert them when they're being so used to this. But overall, I think the fact that younger generations are becoming more wise to this fact will make a very large impact over the next generation or two in China. And we're really seeing this growing movement. We generally always we have a big issue when it comes to China because they're the ones, of course, purchasing a lot of these animals, not just sharks and rays, but a whole wide range of them. But I think there is this growing awareness even in China itself. And we have seen this working with the customs authorities in China, where they're really keen to crack down on illegal trade and to ensure that species listed on CITES are being exported with the appropriate permits and all that. So there is this change taking place even in China, which is incredibly encouraging, of course. Yeah. So the question is whether manta and mobula arrays feed only on plankton. Primarily, yes. We have 1 or 2 mobula species that are potentially feeding on small fish as well, but generally they are filter feeders on almost exclusively on plankton. But yeah, as I said, there are 1 or 2 small species of mobula arrays that are incredibly fast and they can actually catch small fish as well. And their gill plates have adapted slightly to that, so they have a slightly different structure to the other manta arrays. Right. So the question was that CITES deals only on an international level. Is there something on a national level? Because, for example, treasure sharks are being caught here as well. So that's a great question. I mean, like I said, we cannot just focus on one convention to solve the entire issue. This is why we tackle it at various levels. Societies, of course, plays a very large role. The US actually has one of the best treasure shark fisheries in the world off the coast of California, which is actually quite sustainable. So it's very likely that in the coming few months that the US will actually create these non-document findings to certify their stock and actually export treasure sharks at a sustainable level. Looking at other countries, there are issues with certain species. So they may cease to trade them internationally, but they may still catch them at a domestic level. So this is where we had to work with governments on a personal level in each individual country to further national protections of these species as well. Because you have to really approach it from both sides of the spectrum to get a proper protection for all of these species.